Hello. In this video, we're going to look at solving trigonometric equations, pretty basic ones to start. So let's say we have the equation sine theta equals -1/2, and we're trying to solve it for values of theta between 0 and 360 degrees. Now we've seen before that because angles in standard position can be defined in all four quadrants, we actually have an infinite number of possible solutions because we can keep doing rotations over and over and over again. So this domain here is important because it says we're just going to limit ourselves to a single rotation. Let's find all the angles in one full rotation that have this sine value. And because we've seen that the sine value is the y value divided by the radius of the circle, the hypotenuse of the triangle, sine will be negative when the y value is negative. So that happens in quadrants 3 and 4. So we'll have two possible angles, one angle of rotation that goes into quadrant 3 and one angle of rotation that goes into quadrant 4. The next piece that's important is, so first we figure out which quadrants we're looking at. The next piece that's important is figuring out a reference angle. Now, a sine of 1/2 is actually in a special triangle. So we have a special triangle where we have sides of 1, 2, and the square root of 3. That happens when we have angles of 30 degrees and 60 degrees, and we can see from this little diagram that the sine of 30 degrees is 1/2. So here my reference angle is 30 degrees. So that's this angle here and this angle here. So 30 degrees is not one of my solutions, but 30 degrees allows me to find the solutions because theta is going to be 180 degrees plus 30 degrees for the angle in quadrant 3, so that's 210 degrees. Or for the angle in quadrant 4, it's actually going to be 360 degrees minus 30 degrees for 330 degrees. So that means the two possible values of theta in this rotation are 210 degrees or 330 degrees. So those are my two solutions. We follow that similar process for other equations. So for example, the cosine of theta equals -√2/2. Again, we're going to do that one rotation between 0 and 360. So my first concern is where will cosine be negative? So the cosine of an angle of rotation is the x value divided by the radius. And so cosine will be negative when x is negative. And the x value is negative in quadrants 2 and 3. So we'll have an angle of rotation here, and we'll have an angle of rotation there. But what's more important for me initially is figuring out what is alpha, what is the angle, the reference angle. And again, √2/2, that shows up in a special triangle, notably a triangle where we have basically 1/√2, remember, is the same as √2/2. So if I have this isosceles right triangle, that is because I have angles of 45 degrees. So that means that the reference angle here is 45 degrees. So in order to find theta, I consider what the reference angle is and which quadrant I'm in. So for the angle in quadrant 2, it's 180 degrees minus the reference angle, which would be 135 degrees. And for the angle in quadrant 3, it's 180 degrees plus the reference angle, so 225 degrees. So between 0 and 360, the cosine of theta will be -√2/2 if we have theta equals 135 degrees or 225 degrees. So we're going to do one final that isn't in a special triangle. So let's say we have the tangent of theta equals 5/4. Again, a full rotation. So the quadrants, well, tangent is y/x. So the tangent is going to be positive if y and x have the same sign. So y and x have the same sign in quadrant 1 because they're both positive. And they have the same sign in quadrant 3 because they are both negative. And in this case, 5/4, so if I think of a triangle with, so if this is alpha here, if I have 5/4, that's not a special triangle. It's not one of our known ones. So in order to find alpha, I have to use my calculator. So I'm going to figure out what is the arctan of 5/4. And to 3 significant digits, that is 51.3 degrees. So that's alpha and alpha. In this case, because theta is in quadrant 1, then alpha actually is one of the solutions. So theta can be 51.3 degrees. But I also have the quadrant 3 situation, and quadrant 3 is 180 degrees plus alpha, so plus the 51.3 degrees. So again, rounding to 3 significant digits, I lose the decimal place here, so I have 231 degrees. So 231 is my other possible answer, giving me 2 possible angles within that rotation. As a general rule, you're going to find 2 solutions within a single rotation.